hope everyone is fine. This is Doctor from Winners Tutoring Program. We are continuing with the topic functions, but we are dealing specifically with an inverse of a parabola. So you need to know, because they will ask you about the inverse of a parabola and the inverse of an exponential graph. So the hyperbola and the straight line also has an inverse, but the hyperbola doesn't have an inverse. We are not dealing with an inverse of the hyperbola. For today, we are strictly going to be dealing with the inverse of a parabola. So this, for an example, if you are given y is equals to x squared, okay, ax squared plus bx plus c. They won't ask you an inverse of a parabola with a b and a c. So it will always be an inverse of a parabola given in this format, ax squared. You won't be having a b and a c. So for example, let's assume that you are given, let's say x squared in this way. So the first thing that you need to know is to get the equation of the inverse. If you want the equation of an inverse, you interchange x and y. So let us interchange x and y. This one is going to be x, this one will be y squared. You're going to square root both sides. The squared will cancel the square root. Then your y will be plus or minus the root of square. Sorry, root x. So this will be the equation of the inverse. Don't forget, once you square root, you must put a positive and a negative. So this will be the equation of the inverse. But before we move, talk much about the inverse of this one, we must first be knowing the sketch of the original graph. So the original graph is something like this, y, x. So the original graph or equation was given as x squared. So you must know that the x-intercepts, if it's given without b and c, so the x-intercept will be at 0 and 0, y-intercept will be at 0 and 0, then turning point will be at 0 and 0. So this is how it's going to be. So in terms of the shape, because a is positive, it's going to face up. So this is how it's going to be. But let's assume that if a was negative. If a was negative, we're going to have y equals to negative x squared. So same thing, the x-intercept will be 0 and 0. The y-intercept will be 0 and 0. Our turning point will also be 0 and 0. So the shape of this one is still going to turn at the origin. This is how it's going to be. So these are your original functions, these ones. So you need to know their inverse. How are they? And and also you need to know that if is original graph a function, its inverse a function. Those are the things that you need to know. So I want us to first focus on this one. Let's leave the one that is facing down or concave down. We're going to come back to it. So remember, the first thing I said, you must find the equation of the inverse. So the equation of the inverse, we got it. So this one will be f of x. Its inverse, let's check the shape of the inverse. So the original graph, it was given by y equals to x squared. Let's check how the inverse is going to be in terms of the shape. So if you are looking for the shape of the inverse, you can just draw your original function. Draw your original function. Then after you reflect it, and let's check how the shape is going to be. The shape of the inverse. How will it change? So this was our original function. If you are looking for its inverse, the shape, remember we said the equation of the inverse is going to be given by y is equals to plus or minus root of x. This is the equation of the inverse. So if you want the shape of the inverse. You're gonna turn your paper in this way, then flip it to the right, or tilt it to the right, sorry. If you tilt it to the right, its shape is gonna be this one facing that direction. So if you trace it, the shape of the inverse will be in this way. This will be our inverse. We call it Wiener's method. It's the paper method that you always get it at Wiener's. So that's how you get the shape of the inverse. So in this situation, we will check. Remember, I showed you how you go about in terms of getting the equation of the inverse. You must not only know how to get the equation of the inverse, you must also know how the shape is going to be the one of the inverse. So now let's check whether the original graph is a function. So how do you tell that an original graph is a function? If you do a vertical line test in this way, do you see that this vertical line test will always cut the graph only at one point? But let's check which makes this one to be an original function, to be a function. But is this one a function? No. Why is it not going to be a function? Because if I do a vertical line test, do you see that that vertical line test will cut the graph twice at 2 points? So it's supposed to cut it at 1 point. So if they ask you whether the inverse of f, is it a function? Remember, another notation of the inverse is this one. This is a notation of the inverse. So this is not a function. Your reason for you to say it's not a function is because if I draw a vertical line test, our graph will have 2 different points, or this vertical line test will cut the graph more than once. Or you can say we have one x value and many y values. Do you see that the x value for this point, it will be the same as this one and this one, but the y value will be different. So something like that. So we've got one x value and many y values, or it's cutting the graph more than once. That's why it's not a function. That will be the reason that you give. But they can ask you again that, okay, let's throw it in the same set of axes, the original graph and its inverse. So if I draw the original graph, our original graph, it's facing up. This is how it's gonna be. Let's sketch the inverse. The inverse of the graph is gonna be in this way. Do you see that? They are intersecting at 2 points. They are intersecting at how many points? At 2 points. So sometimes you can find it sketched on the same set of axes. So this one, if it's f, the original, then its inverse is given by this symbol. So another thing that we need to know is that this part. Another thing that you need to master or know is that, do you realize that the original graph and its inverse are intersecting here? Another thing is that you need to know that in order for you to get the inverse, you must have reflected. If you reflect f of x, which is this graph, across line y equals to x, you will get its inverse. So, which means the original graph, this one, we reflected across this line. Remember, line y equals to x, it goes in this way. Y equals to x. This is the line y equals to x. Y equals to x. So if you reflect the original graph across the line y equals to x, you're going to get the inverse. So you must clearly understand the question. The question can say, find the equation of an inverse, or they can say find equation with this notation. This and this are the same. Or they can say find the equation or a new equation if we reflect f of x across line y equals to x. So these three questions, they mean the same. So if they say find a new equation if we reflect f of x across line y equals to x, you need to know that you're gonna get its inverse. I've shown you how to get the equation of the inverse and how to draw the inverse using that Wiener's method. Turn the paper, tilt it to the right once, then you trace the shape. So another thing is that, do you realize that these two graphs, they've got a point of intersection. They are intersecting here and there. So we must have two x values. So remember, point of intersection, you must equate the graphs. So we're going to equate the equation of this graph and equate the equation of this graph. So f of x was given by x squared. Its inverse is given by root of x. So can we equate these equations? If we equate these equations, the square root here, the square root here. So this times this is going to be x to the power 4 is equals to an x. So this one you transpose. If you transpose, you're going to get a negative x is equals to a 0. So we will factor out an x. If you factor out an x, you're going to get x cubed minus 1 equals to 0. Then it's going to be x equals to 0, x cubed is equals to 1. If you cube root 1, x equals to 0, x equals to 1. So these are two. The reason why you're getting two values of x is because the graphs are intersecting at 2 points. And they have to make sense even after sketching the graph. Do you see it does make sense that the x value for here is 1? And the x value of, is 0 here, the x value of here. Then the x value for this part is going to be 1. And it does make sense on these answers that we got. So another way of getting this point of intersection, it is in this way. So do you realize that there is this line y equals to x, the one that we reflected f of x across y equals to x. So do you see that this line is also passing at the same points? So if we equate this equation for this graph and the equation of this line, they are intersecting at same points. So the answers, we're supposed to get the same answer, which will be the same x values for the other graph. So we will equate the first equation, which is our line y equals to x, and the other one is going to be x squared. Let's equate these two. Is equals to an x. If you transpose x squared minus x equals to 0, if you factor out an x, you're going to get x minus 1 equals to 0. So x will be equals to 0, x equals to 1. Do you see that you're going to still get the same values? So you can equate this one or this one. The reason why we are equating line y equals to x and f of x is because this line y equals to x is also passing at the same points of intersection between the inverse and f of x. So that is another method. So those are the point of intersection of the two graphs. So now let's check something here. So remember, I asked whether f of x, is it a function? Yes, f of x is a function. Is the inverse a function? Its inverse is not a function. The reason is because if you draw a vertical line test, it cuts it more than once. Or we have many x values and many y values and one x value. That's why it's not a function. It has to have one x value and one y value. But we've got many y values and one x value. That's why it's not a function. So now we are now moving to how do we make its inverse to become a function. To make the inverse to become a function, we must manipulate the original graph. If we change the shape of the original graph, its inverse will also change the shape. So the inverse is dependent on its original, which is f of x. So how do you go about? So the question will say, how can we restrict f of x in order for the inverse to be a function? How can we restrict f of x? What can we do to if f of x so that its inverse become a function? Here they can put this symbol to be a function. So another way of asking it is that how can we restrict domain of f of x in order for its inverse to be a function? Yes. So what we can do is, if we make, let me erase this part. If we make this original function, this one, to only have one arm, remove this other arm, this one. So what happens is that its inverse will also have only one part. It will make it to become a function. So let's do it practically and see how the inverse is going to be. So let's check how the shape is going to change now. Let's check the shape of the inverse, how it's going to be after changing the shape. Alright, here is the original graph, which is f of x. So now f of x is still given by y equals to x squared, where x is greater than 0. So now we want its inverse. I'm showing you how to get the shape of the inverse using the winner's method, the paper method. So if you hold your paper in this way, you turn it, you tilt it to the right. So the shape of the inverse that you're gonna get, we got this shape. This will be our inverse. This is y, this one is x. So let me draw it on the same set of axes, but before that, so do you see that I've made the original graph to have one arm so that this one become a function? Is it a function now? Yes, it's because if you draw a vertical line test, we will have one y value versus one x value, or it only cuts it once. That's why it's now a function. So the question asked you did not ask you to draw the inverse. It asks you, what can we do to the domain of this one? So what we did is that we've made this one to only appear from 0 going that side to infinity, meaning we have made the domain to be in this way, where x will be greater than or equals to 0. Oh, sorry, there's an equal to 0 here. So this is what we've made here. X must be greater than or equals to 0, which means it must appear from here going that direction. So that's how we go about in terms of finding the inverse or restricting the inverse. So in this way, let's draw it on the same set of axes and check how the shapes are gonna be. This one is its inverse, the original function. Let's check its inverse. Its inverse is this one. So this is how its inverse is going to be. Let me just use a different color so that you can see clearly the inverse. This is how the inverse is going to be. This is the inverse of f. So the shape is going to be in that way. You see they are still intersecting at those 2 points. In order for you to get the point of intersection, you're going to equate them the way I've demonstrated there. So now we are now moving, because this is not the only way of restricting it. What if another person did it in this way? What if another person chose to make the original function to only appear this other side, y, x. This is our original function. So its inverse, how is the shape of the inverse going to be? So y is an x. Let's check the shape of the inverse. How it's going to be, the shape of the inverse. So this is our original function. In order for you to get its inverse, you're going to turn your paper like this and tilt it to the right. In this way, the shape that you're going to get is going to be this shape. So this will be the shape of the inverse. So that's how you draw the inverse. So now let us draw it on the same set of axes. Let's check how it's going to be. The original function, which is this one, and its inverse. Its inverse is going to be this one. Do you see they are only intersecting at one point if it's restricted? So this is its inverse. But is now our inverse a function? Yes, because if I draw a vertical line test anywhere on the inverse, I'll get y value versus 1x value. It's now cutting it at only 1 point. So basically this is how you go about in terms of finding the equation or the shape of the inverse. So now I want us to move to how you get the equation of the inverse. Now when it's restricted. Remember we got the equation of the inverse when it was not restricted. Now we want the equation of the inverse when it's restricted. Let's check how do you go about and how do you conclude there in terms of the signs, because after square rooting there will be a positive and a negative. How do you choose the positive or the negative? So you need to know and master that part. So let us check how do you go about. So let's assume that this it's our function f of x. So its inverse, remember I said its inverse, it's gonna be this one. We just did it now. If you apply the paper method, this is what you're gonna get. This is its inverse. So what was the equation of f of x? Equation of f of x, it was y equals to x squared, meaning they've made it to appear where x is greater than or equals to 0, starting from here, going that direction. To get the inverse, interchange x and y. X, y squared, square root. This cancels this. Your y will be plus or minus root x. So how do you choose the sign, positive or negative? Remember, in any x value that we're going to substitute here, it has to be positive all the time because the graph starts from 0 going to all the positive x values. So how is y going to be this side? Y must be positive. So the fact that whatever x value that you're going to substitute here, you're going to get a positive answer for this part that is got a square root, which means the sign for this part, it must also be positive so that it can make the y of this graph to continue to be positive all the time. So the sign that you're going to get is going to be the positive one, so it's going to be root of x. You don't write both positive and negative. You only write positive and negative if the graph only contained both the arms, this part and this part. So this is how you choose. So let us assume if it was in this way now. This is now how our graph is, which is the y. Let's get the inverse. Remember, it's still the same equation there, but its inverse now will appear this other side. If you apply your paper method properly, this will be the inverse. This one is f of x, this one will be the inverse. So how do you go about interchange x and y and so on? Then you're going to get a root of x plus or minus. But which sign are you going to choose now in order that will be proper for this equation? So do you see that every x value that we will substitute here for this graph, it must always be positive. But the y value that you must get, the corresponding y value must get a negative. So in this situation, if what you're going to get here, it must always be positive, then here you must get a negative, so that the y of this graph must be a negative. So our answer will be negative root of x. So this will be the equation for this graph. So it's very, very important for you to know that. So that's how you select. So lastly, I want us to have a look on the one that is facing down. Quickly, we must find its equation. After finding its equation, then sketch the graph. So quickly, before the end of the lesson, you must be able to be mastering this part. Yeah, so it's an easy stuff. After you are being taught, you must have a look, find 5 question papers that has to do with the inverse. Try to apply those methods. We will be uploading other videos very soon that have to do with now applying these basics that we have given you into the question papers. So can you please click into the notification button to be notified whenever we post a new video that will be related to application of this knowledge into question papers. Yes, so now let's go to this one, y equals to a negative, let's say negative 2x squared. Remember what I said, the x-intercept will be 0, y-intercept 0 and 0, the turning point 0 and 0. Our graph is facing down, so the shape of the graph is going to be in this way. Remember, this will be the shape of the graph. It's going to face down. So let's get the shape of the inverse. But before we get the shape of the inverse, I want us to get the equation of the inverse. So it's going to be y equals to negative 2x squared, interchange x and y. So it's going to be a negative 2y squared divided by negative 2 divided by negative 2. This cancels this. So you're going to get this one is still the same as negative 1 over a 2x. Remember, there is a square on y. When we square root both sides, our y will be plus or minus root of negative 1 over a 2x. This will be our equation. So, if this one will be our equation, check something. Its inverse, how is it going to be? Let's check the shape of the inverse. Remember, to check the shape of the inverse, you must be having the original graph, which is this one. Draw it the way you see it. Turn your paper to face that direction, then you tilt it to the right. The shape of the inverse, you're going to trace it. So the shape of the inverse is this one. So it's going to face this direction. So I believe that it's what you're going to get if you find the inverse shape. So is the original graph a function? Yes, it's a function, because in every x value we've got one y value. It's 1:1 function. But is this one a function? It's inverse. No, because if you draw a vertical line test, it will cut it many times. So we've got many y values and one x value. So it's not a function. So how do we restrict this original graph so that this one becomes a function? That will be the question that they will ask you. So your answer will be the same as the previous one. Remember the previous graph, we had to restrict it in this way. To have the original graph only having one arm, or have the original graph having this other arm. So this restriction, we have made x to become greater than or equals to 0. This restriction, we have made x to be less than or equals to 0. So there are how many solutions? 2 solutions. This is how we restricted. So same thing here. If we restrict this one, meaning we make it to only appear this side only, which is f of x. So let's check its inverse. How is it going to be? Its inverse must also have one arm. So let us check the shape of the inverse. How is it going to be? Let us check the shape of the inverse. The shape of the inverse. This is how we have made. This is the original function that we have, f of x. So its inverse, turn your paper and tilt it to the right. So the shape that you're gonna get, this is the shape of the inverse. So let's check. This is the shape that we got for the inverse. This is its inverse. So do you see that we have made the original graph to only have one arm? This one must only also have how many arms? One arm. Is this one a function? Yes, it's now a function, because if you draw a vertical line test, you cut it once. But they want to know, what have you done? Remember what the manipulation that we did it to the original graph. We have made the original graph to only have one arm. So your solution is this. Your restriction was in this way. We have made this one to appear from 0 and to all values that are greater than 0. So this is the first way of restriction. Let's check another way in how you can restrict it. So this is another way of restricting it. Its original function, we make it to only appear this side. Let's check its inverse. How is it going to be? This is f, this is its inverse. So let us check how the inverse shape is gonna be. So you need to know how the shape of the inverse is gonna change. Remember, this is Wiener's method. If you apply it, you will never go wrong. This is its original graph, which is f of x. If you want the inverse, turn your paper in this way and tilt it to the right. So the shape that you're gonna get the shape that is in this way. This is the shape that you're gonna get for the inverse, which is its inverse. So this is how the inverse is gonna be. So let us draw the inverse and the original on the same set of axes. So do you see that the original graph goes like this, which is f of x. Its inverse is gonna go in this way, which is its inverse. So do you see they are intersecting at how many points? At 2 points. So if you solve for point of intersection, you must get those 2 x values. So same thing here, but let's check. Remember, this was the solution. We haven't written the solution for this one. What did we do? We have made it to only appear this side. So its inverse only had one arm. So it's now a function. So what did we do to f of x? We have made f of x to appear from where x is equal to 0 or less than 0. So this will be our solution. So these are 2 solutions for the restriction of the original graph, or restriction of the domain of f. So this is how you go about in terms of dealing with this part. Lastly, now I want us to conclude the lesson, because it's not always that they will give you f of x in that way. What if they've given you something that you usually call it its inverse? Now they give it to you as f of x. Let me just give you an example. Let's assume now they gave you something like this. this is y, this is x. So remember, now they are now giving you something in this way. So then they say it's f of x, and its equation is given by y is equals to, remember, it's going to be a root of x. This is the original function, or it's going to be a 2x or 3x, whatever thing. This is f of x. So remember, it doesn't have, if it was not restricted, it will be having both arms that way. But it's a restricted f of x. So something like this. So now we want the inverse of this one, the equation of the inverse. So remember, when you are looking for the equation of the inverse, interchange x and y, x root of y. You square root, this cancels this. You're gonna have y as x squared. This will be the inverse of this graph. So in terms of the shape, I've shown you how you go about in terms of the shape. If this one is the original function, its inverse, draw this one. Let us draw it practically and see how the inverse is gonna be using this paper method. You can be just trying and apply that method, and let's see how its inverse is going to be. So this is what we were given. If you are looking for its inverse, you turn your paper like this, you tilt it to the right. The shape of the inverse, it's gonna go like this. So this will be its inverse. Yeah. So if this one is having one arm, this one will also have the one arm. So that's how you go about in dealing with this part. So I believe that you are blessed. Don't forget to subscribe into our YouTube channel, share our videos. Don't forget to also click on notification button. May the good Lord bless you. Thank you.